let's look at the sea ice extent March 17 one first.
Awesome. Very
And
telling.
and you can compare 2020 and as I think it was Rick Tolman who sent this out. Basically, the ice situation 2020 looks a lot like the 2004 to 2019 average. It looks a lot like the 2017 year, but compare it to 2018 and 2019.
Jeez.
2019 was really a very low extent.
Which was our second warmest year on record in human history.
Right, right. And of course, we know 2020 had the further ice extent thanks to extremely cold conditions, the very positive AO, along with the high pressure system associated with that, that allowed the sea ice to build up.
Right, the Arctic oscillation in the
Yes.
positive phase, yes.
Very,
a very
strong
high positive
phase.
Very strong. Very strong positive phase.
Very strong positive phase. So we see that there. It's very telling, very dramatically different from one year to the next. Now, is there anything else you want to say on that graphic before we look at the
Just
next
important,
one?
Looking at, once again, the average is telling, the macro scale versus the micro scale each individual year. So that's interesting to look at. This year might be an anomaly in the Arctic. It seems like that, we'll see. We'll see what happens. And then the next graph.
The next graph, you see a slight ticking down towards the median sea ice extent. Slight. You can see how it was lagging. Then we had that cold December, January, so then it surged past the median into greater ice extent. It dipped down to the median, went back up again, and now we're starting to see a dip down towards the median. So really, the sea ice extent for basically December through beginning of March or so, or into mid-March, was basically, hang on a second, I gotta look at this a little closely. From mid-February to mid-March, it's been above the median. And you could even make the argument from the beginning of February to mid-March. It's above the median, but it's starting to tick down. We've actually, as cold as we have been, we've actually been quite warm since last week. I mean, temperatures, we've been actually having temperatures above freezing. And there's actually been some melting beginning.
That's why there's the dip.
But the snow, the forecast is for 5 inches of snow this weekend.
So it's all over the place now.
All over the place. That goes to my point of we perturb the system and you get all this erratic shit going on.
The chaos theory applies?
Chaos theory applying. So when looking at that, you're looking at that the sea ice daily extent, you can see it lagged for most of the season. It wasn't until we had that really cold December and January, then bang. And of course, there's always going to be a delay effect due to the specific heat of the water to finally cool down enough to form the ice. But bang, we got the more ice, more than the median, starting from about the beginning of February, a little dip down, and until now we're starting to dip down again. So, but this will be good because now you have that ice edge productivity, which is important to the ecosystems.
That's right.
So that's an interesting graph there with the sea ice extent. But again, look at the graph there, and you can see. I got to pull this up close and see the red and the green line with a prior two winters, and look, they're like the two lowest.
Right, and then you compare it to the sea ice extent March 17th. You could see those in like graphic format, like the actual sea ice where it actually is. So 2018, they were lower years. 2018, 2019 versus 2020, the winter season.
Exactly. I mean, it shows you the variability that can be inherent in the system. So it's an interesting graph. It shows you right there in a nutshell how things compare. And you can see the last 3 winters.
So real quick, next year, right, the median's going to change, or like that data, that 30-year average is going to change?
Most likely, yes.
Okay.
Yep, exactly.
Something to think about going forward, where I know that, I mean, I don't want to get too into it right now, but that kind of changes the perspective, right? So it's just going to have different averages, I guess, and it's just going to change
Well, remember, the median is the middle point. You have half the
right.
data above it, half below it. So it's what occurs. It's basically what's the 50th percentile.
Okay.
So the median, if you have a perfect normal distribution, then the median and the mean are the exact value.
Okay.
But as I said, when if you have a bunch of values, say in the 20,000s, 30,000s, whatever, and all of a sudden you have a 400,000 value, that's going to take the mean and skew it massively in one direction. So it's going to give, well, I mean, it's sort of like, okay, Michael Jordan walks into the room and we got a bunch of other Joe blokes sitting there, and you basically say, well, the average salary of the people sitting in this room, is $1,900,000.
Exactly.
When it's Michael Jordan sitting there with freaking 15 million, like whatever.
Yeah, it's
But
too
if you look at
skewed.
the median's like, 35,000. But it's like, so
I
yeah,
gotcha. Yeah, the median is a better way of representing the data.
median's a better way to represent central tendency.
Central tendency.
Yeah, that if you want to get a better handle on central tendencies, go with the median.
Okay. Good to
We
know.
use mean because then what's associated with the mean is a plus or minus, which is usually standard deviation. Standard deviation is a measure of the spread of the data. The larger the standard deviation, it's measuring a greater spread among the data. I could have 3 data sets, and let's say the mean for every 3 data sets is 20, whatever it might be. I could have 20 plus or minus 2, plus or minus 11, plus or minus 5. Plus or minus 2 tells me that the data is very tight. The plus or minus 11, good God, that means I have a spread that's greater than half of the average.
Okay.
That tells me
Yeah, it's kind of like a
I've got a
discrepancy.
buckshot of data all over the place.
I gotcha. It's kind of like a margin of error issue kind of situation, right? Or
Margin of error takes standard deviation and then calculates the standard error,
okay.
which is a different. It's a little slightly more involved calculation, but it does incorporate standard deviation into calculating standard error.
Okay, I admit this is new for me.
So the other graphic, do you want to say anything else about the
Just
graphics
once
there?
again, comparing to the previous 2 years, 2 winters, right? It's 2020 is above the median, and be an anomalous year 2020. So we'll see. But
We'll see what happens.